We're going to do a quick mini review of some key features of calculus that will be necessary for completing our course. We won't be using a lot of tools of calculus in solving problems in this class, but some of the terminology or its language will be helpful to us in formulating some of the results that we will use in the class. So ultimately this will be very much an algebra-based course, but the calculus terminology that we use will help us get to some of those results that we'll end up using in calculations. Certainly, it's beyond the scope of our class to go through a full review of calculus, but there's a few central concepts that I want to review. So if we have some function, and it might look like that, there are certain features of the graph of a function that are very helpful to us to be analyzed in calculus. So first, let's pick a couple points on this function. Here might be a location x1 and another location x2. The function, of course, is defined as a set of ordered pairs, so it has a set of y values associated with those two x values. And we can talk about what's sometimes called the average slope. This is always defined over a range of x values. So between any two locations on the function, we can define an average slope between x1 and x2. Sometimes you see the symbol m, and this is defined as y2 minus y1 over x2 minus x1. Graphically, the average slope looks something like this. And it points somewhat down right now. Of course, the average slope might be pointing somewhat up at other places on the graph, but for the two particular values of x1 and x2 that I've chosen, the average slope points down. Another slope that we can sometimes concern ourselves with is what's called the instantaneous slope. And the instantaneous slope is what we mean by that is the slope of the graph as it is heading off to be at a particular value x somewhere on the graph. So we can pick some location like x2. It's sometimes written or described as the tangent, the slope of a tangent line to that function at that point. So if I drew a tangent line here, a tangent line means a line that only touches the graph f of x at exactly one point, and it's going to touch it right there. This is sometimes written as in the form dy dx, so it's like delta y over delta x. But of course, it's taken as at a limit as x1 goes closer and closer to be x2. This delta x in the denominator up here becomes a small infinitesimal distance dx. You might sometimes receive the ratio dy dx written as the derivative of the function f of x, and the derivative is sometimes written with a little prime. And we always have to speak about what is if we want to know the instantaneous slope, we have to know the instantaneous slope at a certain location. So at a certain location like x2. Notice that even though the average slope is pointing down in the example I drew between x1 and x2, the instantaneous slope at x2 itself is pointing up. So it is possible for the average slope and the instantaneous slope to be different. And that's why when we talk about averages, they're very useful, but the instantaneous value might be more useful to us depending on the example we're doing. Now this function called the derivative is itself a function. It is itself a function. It's the derivative of that function, but if we were to graph what does f prime of x look like, it also describes a set of xy pairs. So we can graph it and it becomes a function itself. Now I will notice here that there are a couple locations where this function f prime, the derivative, is 0. I notice that because when I look right there, the tangent line would be horizontal. So I want to come down, and I'm going to know that the derivative goes through 0 right there. By the same token, the tangent line here is horizontal. And so the derivative should be going through 0 right there. What is it doing elsewhere? Well, if I were to draw a tangent line to the function anywhere along this side, it would be a positive number. If I were to draw a tangent line somewhere in this region, it would be a negative number, or it would have a negative slope. So since the derivative at that location gives me the slope of the tangent line at that location, I need to be thinking about a graph that looks something like this. Now that's not necessarily drawn precisely, but it's somewhat to give you an idea of what the general trend is. Notice that this function, the derivative, does not necessarily go to 0 when the function goes to 0. In fact, it's 0 when f of x is positive. And it's not the case that this thing will be negative when f of x is negative. In fact, it's right here negative, even though f of x is positive. So what the derivative tells us more about is what the function f of x is trending toward. If this is negative, that means that the regular function itself is getting smaller. If it's positive, it means it's getting larger. So we'll have to be very careful what we mean by when something is positive or negative. In the case of the derivative, it tells us about trend. In the case of the function itself, it tells us about the value.